morning, students. Hope you all are fine and safe. Today we are going to study Science 1. Students, in second lesson of Science 1, we have studied that in our surrounding there are various states of matter, that is solid, liquid and gas, and these were further classified as elements in periodic table. These elements were studied according to the similar characteristics which were further known as metals, non-metals and metalloids. So students, today we will study lesson number 8 of Science 1, that is metallurgy. Metallurgy means the branch of science and technology concerned with the properties of metals and their production and purification. In this lesson, we will study physical properties of metals, chemical properties of metals, chemical properties of non-metals, metallurgy, various concepts, physical properties of non-metals, reactivity series of metals, and ionic compounds. Earth was born about 4.5 billion years ago. Various formative processes have been taking place in the core of the earth and its surrounding since its creation till today. These have resulted in the formation of various ores, liquid and gases. The substance around us are in the form of some or other elements or their compounds. In the beginning, elements were classified in accordance to their chemical and physical properties into the types metals, non-metals and metalloids, and these are even used today. You have studied their characteristics in the last standard. We are going to get more information about them in this lesson. Students, can you tell what are the physical properties of metals and non-metals? As you all are aware about, metals and non-metals are elements. Can you look around and see if they exist in your surrounding? What is your table made up of? Aluminium or wood? What about the phone or laptop you are viewing this video on? Is it made up of metals and non-metals? As a matter of fact, it is. Almost everything around will be made up of either metals or non-metal. But how do you differentiate between these two? Is it as easy as difference between the color black and white? Well, for that, let us look at the physical properties of each category in detail. Let us take, for example, ornaments. Any of the ornaments will do. What do you have to say about them? You will observe most of them are made up of gold or silver. Let us look at them closely. Do they have the shiny surface? Or even though aluminium utensils in kitchen, does it shine? Of course, both gold and aluminium have a certain shine. Do you know what this shine is called? Well, it is called luster, and both aluminium and gold are metals. This is known as metallic luster. Now we know that metals have a metallic luster. Now, if the utensils fall on the floor, does it break into parts? No, right? That is because metals are generally hard in nature. However, this hardness varies from metals to metal. A very thin plate of a gold, for example, can be easily broken with a little pressure. Did I say plate of gold? How do you think huge aluminium sheets are made, or sheet of copper or zinc? If I take a hammer and beat them, will they break or will they turn into sheet? It is the amazing property of metal to be beaten into sheet, and we call this property of metals as malleability of metals. Most of metal can be beaten into thin sheet. Do you know another important properties of metals? Have you ever seen copper wire or a thin gold wire used to make jewelry? Metals by nature can also be drawn into wire. Do you have any clue what this property is called? It's called ductility of metal. The ability of a metal to be drawn into wire is called ductility. There is an amazing fact that I want you to know. A single gram of gold can be drawn into 2 kilometer long wire. Isn't that amazing? So, we have learned four properties of metal, that is metallic luster, malleability, ductility, and that they are hard. Can you think some more properties of metals? Metals utensils are used for cooking, aren't they? Why do you think that they are used for this purpose? Which energy do we need to cook food? Heat energy, correct? We need heat energy to cook food, and metal utensils are good conductor of heat. They help to transfer heat evenly through the entire surface and provided even heating. No doubt, most of metals are good conductor of heat. Do you know two best conductor of heat? They are silver and copper. Two are the metals. Lead and mercury are comparatively poor conductor of heat. Electric wires were also made up of metals, right? Why is that? It's because they are good conductor of electricity too. If we have a battery and a bulb connected in a circuit with a metal wire, you will see that the bulb will glow. And because they are good conductor of electricity, they are coated with a rubber-like material. This rubber-like material acts as an insulator which protect us from being electrocuted if we touch the wire by mistakenly. Do you know any other properties of metals? What happens when we strike a metal on a hard surface like utensils, banging against the sink? Can you hear a sound produced by metal? Yes, this is another property of metals. We can call metals as sonorous. They produce sound when hit against a hard surface. No doubt, school bells, church bells, or the bells in the temple are made up of metals. If these are the characteristics of metal, what do you think will be the characteristics of non-metals? In simple words, just the opposite of metals. In nature, non-metals like carbon, iodine, sulfur do not have luster. They do not shine and are brittle in nature. What do you mean by brittle? They cannot be beaten into sheet or wire, as most of them turn into powder when hit by a hard substance. Non-metals can also be gaseous like oxygen, hydrogen, or solid like carbon and sulfur, etc. Do you know any non-metal in liquid state? Yes. Bromine is only non-metals which is in liquid state. Non-metals do not conduct heat or electricity, and they do not produce the sound when they are hit against the hard substance. This means they do not have the property of sonority. So, isn't it easy to differentiate between metals and non-metals? Only on the basis of physical properties? Wait, but mercury is a metal in liquid state at room temperature and bromine is a non-metal in liquid state at room temperature. How do we differentiate these two based on physical properties? We can say all metals are solid at room temperature except mercury, and all non-metals are in solid or gaseous at room temperature except bromine. Well, this is not it. There are more of few which breaks the physical appearance norms of metals and non-metals. For example, most metals have high melting point, which means they need a large amount of heat to melt. But look at the two metals, gallium and cesium. They melt when you keep them on your palm. We must see that these two metals, however, have very low melting point. Look at the another exception in non-metals. Iodine, for example, is a non-metal, but it has the property of metals. Can you point out which property I am talking about? Correct, the luster. Iodine have luster, which is technically the property of metals. Take another example, carbon. For instance, what is carbon? It is a metal or non-metal. Yes, carbon is non-metal. But look at diamond or graphite, they all come from carbon. They are known as allotropes. The different form in which carbon can exist are called its allotropes. Let us look at the allotropes diamond of carbon. It is known as the hardest substance. It has the extremely high melting and boiling point. Aren't these properties of metal? But it is surprising that diamond is an allotrope of carbon, which is non-metals. Diamond too is a non-metal which strongly exhibit the properties of metals. Now that we know so many exceptions, do you think it's easy to differentiate between metals and non-metal based on the physical properties? I doubt that, but does not worry. There is another way out of this. It is the to differentiate between them between the chemical properties. How is that done? We saw that elements cannot be clearly classified between metals and non-metal based on their physical properties. Will chemical properties help? Let's understand chemical properties of metals first. Metals are reactive. They lose electrons easily and become positively charged ions. That is why metals are called as electropositive elements. When we are looking at chemical properties of metals, there are few things which we look at. We will see what happens when metals burn in air or in presence of oxygen. When metals react with water, when metals react with acid, and lastly when metals react with solution of other metal salts. Now, in all these four categories, this is just one simple thing we will do. We will look at how reactive the metals are. If the metals react easily, may it with oxygen or air or anything else, we will say that they are more reactive. When it is more difficult for them to react, we will say that they are less reactive. Let's focus on first category. Metals burn in air or reaction of metals with oxygen. The most important point to note here is that almost all metals react with oxygen to form metal oxide. These metal oxide which are formed are usually basic, but they can also be amphoteric. What do you mean by amphoteric? Metal oxide which may show acidic as well as basic behavior are known as amphoteric oxide. Most metal oxides are insoluble in water, but some metals also dissolve to form alkali. So, metal oxide being formed one thing, but do all metals react with oxygen at same rate? Not really. Different metals shows different level of reactivity towards oxygen. Alkaline metals such as sodium and potassium react vigorously with oxygen. In fact, they react even if they are just kept in open, even that is at room temperature. They don't even need fire to ignite the reaction. What about the other metals? Metals such as magnesium, aluminium, zinc and lead also react with oxygen at room temperature, but they react a bit differently. When they react with oxygen, their surfaces get covered with a thin protective layer of oxide. This layer protects the inner part from being oxidized. What about iron? Iron does not burn on heating, but iron filings burn vigorously after being heated. And which metals do we have at the end of the spectrum? Yes, silver and gold. Can you guess how they react with oxygen when they get burned? Silver and gold do not react with oxygen at all. Yes, they do not react even at high temperature. So we see somewhat of pattern even among the metals. Sodium and potassium are more reactive, whereas magnesium is reactively less reactive. But wait, burning in oxygen does not really help us to decide the reactivity of iron, zinc, lead or copper. All we know about them, these four, is that they form a thin layer of oxide around the metals. So just these categories of burning metal in air isn't enough for us to judge the order of reactivity of these metals. We can see a few more reactions to judge the order of reactivity. We will take the same sample of metals to check out how they react with water. Don't forget, our basic aim is to find out the order of reactivity of these metals. If a metal reacts more vigorously with water, then it is said to be more reactive than one that does not react as much. In general, metals react with water to form metal oxides and hydrogen gas. If metal oxide form is soluble in water, it will dissolve to further to form metal hydroxide. So, how can we judge the order of reactivity based on their reaction with water? We perform a simple task. First, we take a beaker half filled with cold water and see how the metal react with it. Some of the metals will react with cold water, but most of them won't. Out of those metals which did not react with cold water, we will try to add them to hot water and see how they react. Again, some will react with hot water and some won't. Those set which won't react with hot water, we will see how they react with steam, and that will give us a kind of reactivity. Ones which react easily with cold water are more reactive, and the one which required steam are less reactive. Metals like potassium and sodium react vigorously with cold water. In case of these two metals, the reaction is so violent that they evolve hydrogen gas and immediately catches fire. So we know sodium and potassium are highly reactive. Remember, we are still talking about reaction with cold water. How does calcium react with cold water? Well, calcium does react with cold water, but the reaction is not violent, as we have seen with potassium and sodium. The heat is not enough for hydrogen to catch fire, but what happens is that the calcium starts floating because bubbles of the hydrogen gas formed stick to the surface of the metals. Now, let us see magnesium. Does it react with cold water? No, it does not. But magnesium reacts with hot water to form magnesium hydroxide and hydrogen gas. Just like calcium, it starts floating due to the hydrogen gas sticking to the surface. The remaining metals we see here don't react with hot water or cold water, but aluminium, iron, zinc react with steam to form metal oxide and hydrogen gas. And the other metals like lead, copper, silver and gold don't react with water at all. Now let's see reaction of metals with acid. In earlier chapters, we have studied reaction of metal with acid. There are many metals which react with dilute acid and they produce hydrogen gas. To prove the given reaction, let us perform an experiment. For doing this experiment, we need some material such as stand, test tube, delivery tube, rubber cork, glass rod with soap water, zinc granules and hydrochloric acid. Take about 10 ml of dilute hydrochloric acid in a test tube. Add few zinc granules to it. Close the test tube with one holed rubber cork containing delivery tube. Place another end of delivery tube into the soap water. Observe it. Gas-filled bubbles are formed in the soap solution. Observe once again carefully. Gas bubbles are evolved from the surface of the zinc granules in the acid. These gas bubbles are captured as a gas bubbles in the soap water. When we keep a burning splint near gas bubbles, observe carefully what will happen. Gas explode with a pop sound. This indicates that the gas evolved is hydrogen gas. If we repeat the above experiment by using other acids like sulfuric acid and nitric acid, we get hydrogen gas. From the above activity, we can conclude that when acids reacts with metal, hydrogen gas is evolved and sulfate or salts of the metal are formed. Similarly, hydrochloric acid reacts with magnesium, aluminium, iron, and the reactivity of the metal can be indicated by the following sequence. That is, magnesium is more reactive than aluminium, aluminium is more reactive than zinc, and zinc is more reactive than iron. Now let us see how nitric acid reacts with metals. Acid reacts with metal to form salt and hydrogen gas. But nitric acid does not produce hydrogen when it is reacted with metals. The reason behind is it is a strong oxidizing agent. Oxidizing agent means which provides oxygen. So nitric acid oxidizes the hydrogen gas to form water. Therefore, nitric acid does not form hydrogen gas on reaction with metals. Does nitric acid produces hydrogen with any metals? Yes. These are few metals which react with dilute nitric acid to produce hydrogen gas. They are magnesium and manganese. When magnesium or manganese react with dilute nitric acid, it forms salt and hydrogen gas. As nitric acid is a strong oxidizing agent, nitrate salts of metals are formed on reaction of metals with nitric acid. Various oxides of nitrogen like nitrous oxide, nitrogen oxide and nitrogen dioxides are also formed in accordance with concentration of nitric acid. Students, what is aqua regia? Aqua regia is a highly corrosive and fuming liquid. It is one of the few reagents which can dissolve noble metals like gold and platinum. Aqua regia is freshly prepared by mixing concentrated hydrochloric acid and concentrated nitric acid in the ratio 3:1. Now let's see reaction of metals with salt of other metals. How do metals react with solution of other metal salts? The concept is simple. The more reactive metal will displace the less reactive metal. If metal A is more reactive than metal B, then salt of metal A will be formed. Let's perform a simple experiment to prove this. Take a clean copper wire and a clean iron nail. We need two solutions, that is solution of iron sulfate and solution of copper sulfate. Dip the copper wire in ferrous sulfate solution and iron nail in copper sulfate solution. Keep on observing continuously at a fixed interval of time, that is about half an hour. In which test tube a reaction has taken place? The reaction has taken place in the test tube containing iron nail. How did you recognize that reaction has taken place? That is because blue color copper sulfate solution has turned colorless. What is a type of reaction? It is a displacement reaction. We see that the nail is coated with pinkish brown deposit, which is nothing but copper, and don't assume it rust. It is not rust, it happens because iron has displaced copper from copper sulfate. If this reaction continues for few hours, the large amount of copper will be displaced from the copper sulfate solution and iron takes its place to form iron sulfate solution, which is green in color. What about the reaction in another test tube? Yes, there is no reaction at all, and that's because iron is more reactive than copper. Copper will not displace the iron. So, what are we trying to learn here? Our aim in all these experiments was to find out the order of reactivity of metals. Making metals react with oxygen, water and acid gives us a brief idea about order, and conducting such many experiments will also gives us idea of which metals are more reactive. So, after many experiments and tries, the following reactivity series develop. The reactivity of the metals decreases as we move from top towards bottom. Now let us see reactions of metals with non-metals. Noble gas like lithium, helium, neon, argon do not take part in chemical reaction. So far, we have seen from the reactions of metals that cations are formed by oxidation of metals. If we look into electronic configuration of some metals and non-metals, it will be seen that driving force behind a reaction is to attain the electronic configuration of the nearest noble gas with complete octet. Metals do this by losing electrons, while non-metals do this by gaining electrons. The outermost shell of noble gases being completely filled, they are chemically inert. You have seen in last standard that the ionic compound sodium chloride is formed and sodium metal gives away one electron while non-metal chlorine takes up one electron. Therefore, when sodium is reacted with chlorine, sodium chloride is formed. Now let us study chemical properties of nonmetals. Nonmetals are collection of elements having less similarities in physical and chemical properties. Nonmetals are also called electronegative elements as they form negative charge ion by accepting electrons. Some examples of chemical reactions of nonmetals are as follows. First one, reactions of nonmetals with oxygen. When nonmetals react with oxygen, they form nonmetal oxide. For example, the nonmetal carbon. Carbon react with oxygen to form carbon dioxide, that is CO2. This can be seen during burning of coal. When coal is burned in presence of oxygen, it forms carbon dioxide. Let's see one more non-metal, that is sulfur. When we take sulfur powder in a spatula and heat it, it forms sulfur dioxide gas. We collect this gas in a test tube. Now let's test this gas. Let's see whether it is acidic or basic. For that, we will use litmus paper. We will use dry blue litmus paper. When dry blue litmus paper comes in contact with sulfur dioxide, we will see no change. But if we take a moist blue litmus paper, we will see that the litmus paper is changing from blue to red. This indicates that sulfur dioxide gas is acidic. But why it did not show any change on dry litmus paper? That is because acidic properties are seen only in presence of water. This indicates that sulfur dioxide is acidic. Let's take carbon dioxide. If we test carbon dioxide, we will find the same thing. The blue litmus change red. That means carbon dioxide is acidic. So, generally we say non-metal oxides are acidic in nature. Now, what will happen when non-metal oxides comes in contact with water? When carbon dioxide comes in contact with water, it forms acid, that is carbonic acid. And sulfur dioxide, that is SO2, comes in contact with water, it forms sulfurous acid, that is H2SO3 gas, due to which when these gases comes in contact with moist blue litmus paper which has water in it turns red. But there are certain metal oxide like carbon monoxide, nitrogen monoxide, dinitrogen oxide, water, all these are neutral oxide. So we can say that generally non-metal oxides are acid in nature except carbon monoxide, nitrogen monoxide, dinitrogen oxide, water, etc. Note this nitrous oxide, that is N2O, is also known as laughing gas. Second one, reactions of non-metal with water. Generally, non-metals do not react with water except halogens. For example, chlorine on dissolving in water gives following reaction. That is, chlorine reacts with water to form hydrogen hypochlorite and hydrochloric acid is formed. Third one, reactions of dilute acid with nonmetal. Generally, nonmetals do not react with dilute acid. Halogens are exception to this. For example, chlorine reacts with dilute hydrochloric acid by the following reaction. Chlorine reacts with hydrogen bromide to form hydrochloric acid and bromine. Fourth one, reactions of nonmetals with hydrogen. Nonmetals react with hydrogen under certain conditions such as proper temperature, pressure, use of catalyst, etc. For example, sulfur react with hydrogen gas to form hydrogen sulfide. Nitrogen react with hydrogen to form ammonia. So students, today we have studied physical and chemical properties of metals and non-metals. Hope you have understood the topic. Stay home, stay safe. Thank you.